so this is chapter 3, numerical method. So 3.2, Newton-Raphson method. So we are going to find the root for an equation using the formula xn plus 1 equal to xn minus fxn over f prime xn. So we're going to use this formula to find out the root of an equation. Okay, so let's straightaway go to the first example. Show that the equation ex equal to 4 sine x has a root between x equal to 1 and x equal to 2, and find this root correct to 3 significant figures. So what do we have is ex equal to 4 sine x. So firstly, we need to know what is our fx. So one side of them should be equal to 0. So you can either bring this one to the right hand side or bring this one to the left hand side. So we are going to have ex minus 4 sine x equal to 0. Okay, so ex minus 4 sine x equal to 0. So we're going to call this one as fx equal to ex minus 4 sine x. So we have to show that we have a root between 1 and 2. So firstly, substitute with 1 first. F1 is e to the power of 1 minus with 4 sine of 1. So don't forget, the mode of your calculator should be in radian because we have some trigonometric function. So this is negative 0.648. So we're going to do the same thing for f of 2. So this is e2 minus 4 sine 2. So this is 3.752. Okay, so as you can see, this is negative. So this is less than 0. So this is positive, greater than 0. Since this one we have opposite sign, because one of them is positive, one of them is negative. Therefore, we can see that there is a root between x equal to 1 and x equal to 2. So this is how we prove that we have a root between x equal to 1 and x equal to 2. So substitute into fx and then show that you have opposite sign. So one of them should be positive, one of them should be negative. Therefore, there is a root between x equal to 1 and x equal to 2. Okay, so straight away, I want to do the Newton-Raphson. So the first step, I need to again write down my fx. So fx is e to the power of x minus 4 sine x. And then make sure you differentiate them to get f prime of x. So differentiating ex is simply ex. Differentiating this one will simply give me negative 4 cos of x. So differentiating sign, we are going to get cos. Okay, so substitute into the formula. So since we know that there is a root between x equal to 1 and x equal to 2, so my first root, I'm going to take somewhere in between 1 and 2. So let us try 1.5. So the formula is xn plus 1 equal to xn minus fxn over f prime xn. So that means for x2, this is x1 minus fx1 over f prime x1. So substitute here 1.5 minus fx1. So substitute with 1.5. So e 1.5 minus 4 sine 1.5 over e to the power of 1.5 minus 4 cos 1.5. So the answer for this one is 1.3829. So this is the second one. So let us do the same thing for x3. So this is 1.3829 minus e to the power of 1.3829 minus 4 sine 1.3829. to 9 over e to the power of 1.3829 minus 4 cos 1.3829. So this is 1.3653. So we are going to do the same thing for x4. So again, keep on repeating the same thing. So this is 1.3653 minus e to the power of 1.3653 minus 4 sine 1.3653 over e to the power of 1.3653 minus with 4 cos 1.3653. Okay, so this one is 1.3650. Okay, so you're gonna repeat again to get x5. So repeat the same procedure. So what do we have is 1.3650. Okay, so now once you get the same number twice, then that is the third step, which is stopping criteria. So if you keep on repeating the same number twice, then you can stop them. So I see them 1.3650, 1.3650. So I can stop until x5. So now we have to write down our answer. Therefore, triple dot x is equal to. So now go back 3 significant figures. That means this one is 1.37 up to 3 significant figures. Okay, so I need to remind you one thing. If the question asks for 3 significant figures, as you can see, for my working, it is always more than that. So for our working, it should always be more than what the question wants. But for your final answer, you should follow the question. If the question said 3 significant figures, your answer should also be 3 significant figures. Okay, so example 2 show that the equation 2x cubed plus x squared equal to 33 has a root between 2 and 2.5, and find this root correct to 3 significant figures. So the firstly, copy down the function, the equation. So firstly, copy down the equation. So 2x cubed plus x squared equal to 33. In order to have our fx, we have to bring this one to the left hand side or bring this one to the right hand side. But let me bring 33 to the left hand side. So 2x cubed plus with x squared minus 33 equal to 0. And since one side of it is already equal to 0, I'm going to call fx equal to 2x cubed plus x squared minus 33. Okay, so now we have to show we have a root between 2 and 2.5. So f of 2 is equal to 2 multiplied with 2 cubed plus with 2 square minus with 33. And then by using our calculator, we should be able to see that this is equal to negative 13, which is less than 0. And then substitute 2.5. So what do we get is 2.5 cubed plus with 2.5 square minus with 33, and the answer for this one is 4.5, which is greater than 0. As you can see over here, we have opposite sign. So since we have opposite sign, we can say that there is a root between 2 and 2.5. Okay, so now let us find the root by using Newton-Raphson. So fx is 2x cubed plus with x squared minus 33. So f prime of x, differentiating 2x cubed, we're going to get 6x squared plus with 2x. Second, let us substitute into the formula. So we need to have the first initial value. So x1, we have to choose somewhere in between 2 and 2.5. Let me choose 2.3. If you want to, you can choose 2.1 or 2.2 as well. So x1 is 2.3. So x2, by using the formula, we know that xn plus 1 is equal to xn minus fxn over f prime xn. So substitute into the formula, we are going to get 2.3 minus, so 2 multiplied with 2.3 cube plus with 2.3 square minus 33 over, so the denominator now is 6, 2.3 square plus with 2 multiplied with 2.3. So if you look at the question asks for 3 significant figures. So let us give our answer in 4 decimal places. So using our calculator, we can see that this answer is 2.3929. So this is not similar with x1, so let us proceed with x3. So 2.3929 minus 2, 2.3929 cube plus with 2.3929 square minus 33 over 6 multiply with 2.3929 square plus with 2 multiply with 2.3929. So now again using our calculator, this is 2.3896. So these two are not similar yet, so let us do another iteration. So this is 2.3896 minus 2 multiplied with 2.3896 cube plus 2.3896 square minus 33 over, so 6 multiplied with 2.3896 square plus with 2 multiply with 2.3896. So again, by using our calculator, this is 2.3896. Okay, so this is similar. So both of them are similar. Therefore, this is our third step where we stop because they are similar. Okay, so now let us write down our answer. Therefore, x is equal to 2.39. So this is correct up to 3 significant figures.